Oh. So welcome to the live session of the course, the machine learning and the deep learning, fundamentals and applications. So this is the first live session of the course. That is the NPTEL course on machine learning and deep learning, fundamentals and applications. So if you have any questions, then you can discuss with me in this live session. And in the shared Excel file, I have only one question. So that question I can discuss. The first question is, what is the difference between the machine learning and the deep learning? So that is the only question I have seen in my Excel file. So comparison of the machine learning and the deep learning. So in the first class, I mentioned that in machine learning, mainly we are considering the statistical machine learning techniques. And what is the objective of the machine learning? So mathematically, I have explained that we have to consider the problem of determining the probability of omega I given x. That is the probability of finding a particular class given the Fisher vector. So that is actually the statistical machine learning. Now, another way is the subcomputing based machine learning techniques. Maybe we can consider fuzzy logic, artificial neural networks, genetic algorithms, genetic programmings. So we can consider these techniques for machine learning. So that is actually the subcomputing based machine learning. And if you see the distinction between the machine learning and the deep learning, mainly the deep learning is the advanced version of the artificial neural networks. So there are some problems in case of the artificial neural networks. So these problems can be considered in case of the deep learning. So deep learning is a subset of machine learning, and mainly it is the artificial neural network. And there are some cases that the problems of the artificial neural networks that are considered in case of the deep architecture, that is the deep learning techniques. So that is the fundamental difference between the machine learning and the deep learning. So that is the only question I have seen in my Excel file. So now, if you have any questions, then just you write in the chat box. So I will try to discuss. So if you have any questions, then you can put in the chat box. Is it okay now? Is it okay? The camera is on. So is it okay now? No, in my screen it is visible. So is it okay now? Camera is okay now? Is it camera is okay now? So maybe I can I connect the Microsoft Team again? MS Team? Oh. So if you have any questions, then you can put in the chat box. I am available. So this is the first live session of the course on machine learning and deep learning, fundamentals and applications. So up till now, we have discussed up to week number 4, and week number 5 is going on. So up till now, we discussed the concept of the machine learning. After this, we discussed the concept of the performance evaluation of the classifier. Like we discussed the concept of the accuracy, confusion matrix, and also the F1 score, the ROC, receiver operating characteristics, and also the concept of the bias and the variance. And after this, we discussed the concept of the regression. After this, I discussed the concept of the Bayesian decision making. So in the Bayesian decision making, we considered the classification problem. And after this, we discuss the binary classification problem, that is the Bayes classifier, and the concept of the risks in the classification. And also we discuss the concept of the parameter estimation, the parametric estimation, and the non-parametric estimation. So if you have any questions, then you can write in the chat box. I am available here. So if you have any questions, then you can write in the chat box. I am available here. So the NPTEL team, whether my video is available now? Okay, in my system, it is coming. Okay. So hierarchical clustering, the mean shift clustering. So these clustering techniques we'll be discussing in week number 9. Week number 10, we'll be discussing the concept of the artificial neural networks. So one important point is the radial basis function. So that point also I'll be discussing. And week number 11 is mainly the deep architectures. So we'll be discussing the concept of the convolutional neural network and the concept of the AliNet 5, DNet 5, LXNet, PGGNet, GoogleNet, residual net. So all these concepts I'll be discussing in week number 11. And week number 12 is mainly the recent trends in deep learning. So we will discuss about the generative adversarial network, autoencoders, the relationship with the PCA, recurrent neural networks, and some of the applications, and also the programming concepts. So this is the course outline that we are considering. So for this first live session of the course, up to week number 4 or maybe the week number 5, if you have any questions, then you can write in the chat box, and I will try to discuss. So if you have any questions, then you can write in the chat box. So I am here for a discussion. So any questions you can write in the chat box up to week number 5. Then we can discuss. So if you have any questions, you can write in the chat box. So that is in the YouTube chat box is available. So in the YouTube chat box, you can write the questions. So any questions you can write in the chat box that is available in the YouTube. Oh, in the team chat box, it is there. Okay. So one question is this maximum likelihood estimation is what you are writing. So generally in maximum likelihood cases, we are considering the binomial distribution because we are considering the modeling the binary outcomes for many trials. So either it may be 1 or it may be 0. So that also we can consider. But this maximum likelihood estimation can be considered for other distribution also. So if you see some other books like the Fukunga, one book is that's a very popular book. So maximum likelihood estimation that can be also considered for other distribution, but some mathematical analysis is there. But in my discussion, I discussed that that based on the binomial distribution, we can consider that problem. So one question is that kindly give some ideas for the final exam. So for the final exam, I think you have to see the assignments, the weekly assignments. The weekly assignments are more mathematical, but for the final exam, only you need to see the videos. And the books already I have mentioned in the first class, that is the book by Duda and Hart. So the book is mainly the Duda and Hart, and also another book is the Bishop. So these two books you have to see, and mainly you have to see the videos. If you understand the videos, then this multiple choice the questions, that may not be difficult. So from the beginning, you try to see the videos, and the questions may be some the concept oriented questions. Around 40% question will be mathematical and 60% basically the concept type. So what is RBF, radial basis function? What is that base decision theory? Based on the base decision theory, you can get some questions. So if you have good understanding, then I think you can answer these questions. That is not a difficult one. So mainly you have to see the videos, and along with this, you have to see the videos, the books. Sorry. So this maximum likelihood estimation is not like this. You are considering the binomial distribution. This is for the one example we are considering, because it's a binary trial. So either it may be 1 or it may be 0. So that point we are considering. But we may consider different distributions. But mathematical derivations will be different. And mainly we should consider the normal distribution, the Gaussian distribution. So if you have any questions, you can write in the chat box of the YouTube, or maybe in the MS team, you can write some questions. So exam preparation is not so difficult. Only you have to see at least the 2 to 3 times a particular video. So you see the videos at least for 2 to 3 times and write the main points in your notebook. Then I think you can answer the questions. So only 40–50% questions will be mathematical type. The rest will be on understanding basis. So one question is what if the one of the feature probability is 0 plus conditional probability? How? So that means the sums of considering that particular class will be minimum. So what if the one of the feature probability is 0? 0 means there is, that means you are considering the probability of x given omega I. So if the probability of x given omega I is equal to 0, then this probability of omega I given x, that will be also 0. So if I consider the probability of x given omega I, that is the class conditional density, if it is 0, then the probability of omega I given x, that is the posterior probability, that will be also 0. Yes, among many features, one feature is 0, then map will be 0. Yes. So, but in this case, we have to consider the case of the feature selection. That means we have to select the most discriminative features. That means that feature has no information. And because of that feature, the classification accuracy goes down. So that is why the feature selection is important. One feature is 0, that I'm not getting. That class conditional density will be 0. No, there are many techniques for this. One is also, yes, I know that is the Laplace smoothing is also there, but the dimension of the feature vector that you have to see. The feature selection is important. So there are many techniques to consider that case. But whenever the class conditional density is 0, then this probability of omega I given x, that will be also 0 in case of the Bayesian decision making. Because this is not the important feature. So one bad feature may affect other features. So it will affect the classification. So that is why we have to consider the most discriminated features. So that is why the feature selection is important. So if you have any questions, then we can discuss. So up to week number 4 and week number 5. Up to week number 5, we can discuss. So in this course, we have another 2-3 live sessions. Then time also we can discuss. If you have any doubts, that also you can discuss with my TAs of the course. So you send the mail in the portal, and my TAs already I have instructed them to discuss with me. And most of the questions will be answered by the TAs. So for any difficult questions, they will interact with me. And after this, we can give the solution of this. So one question is difference between linear discriminant function and classification. Any difference? No, this linear discriminant function we are considering for the classification. So the linear discriminant function is the CIX. That is the discriminant function. And based on the discriminant function, we can take a classification decision. So because for C number of classes, we have C number of discriminant functions. And we have to select the which one is the maximum. That out of C number of discriminant function, which one is the maximum, that we have to select. And based on this, we can consider the classification problem. That means we can select a particular class. So that is the discriminant function is considered for the classification. So out of C number of discriminant function, which one is the maximum, that we have to select, that we have to identify. And based on this, we can select a particular class. So that is why the discriminant function can be considered for classification. The discriminant function is the ZIX that I have discussed in the class. If you see my video, then I have discussed about the discriminant function. That is the linear discriminant function. So yes, very good. That this question is very important. So the question of the discriminant function is important. So Vikrant, you are from which institute? Vikrant. Okay, BMS College, Bangalore. Yes. So BMS College, Bangalore. Is it from Bangalore? Yes. So after this, we have another 2, 3 live sessions of the course. So that time also we can discuss. So up to week number 4 or 5, we can discuss here. So how does the optimal decision in Bayes decision theory minimize the loss function? So I'm not getting this question. What do you mean by this? In Bayes decision theory, we have to determine the probability of omega I given x. That we have to determine. Minimize the loss function. What theory that minimize the loss function? So what loss function? Because in the Bayes decision theory, we considered that finding the probability of omega I given x, and that is from the information of the prior probability of omega I, and another one is the probability of x given omega I. So one is the prior probability and another one is the class conditional density. That is the likelihood. So now the loss function is which loss function? Because if you see that when we discussed about the perceptron criterion, we discussed the concept of the gradient descent algorithm. So this loss function is mainly that I think this question is loss function is that Rix. The Rix is that is one is the probability of error, and another one is the Rix. So this concept of the Rix we discussed in the class. So loss function is mainly the Rix we discussed, and that is the minimum error rate classification. If you remember what is the minimum error rate classification? In minimum error rate classification, we discussed about the loss function. So I think that is the answer of this question. So we discussed about the minimum error rate classification. If you see the video, we consider the minimum error rate classification. So for the minimum error rate classification, we discussed the loss function and also we discussed the concept of the risks. So how to minimize the risks? So that is the case. So these assignment questions, what you can do, if you find the problems here, you can send this your mail in the portal. So in the portal, it is there. So just from the portal, you can put these questions. And my TAs, they are making some of these questions. So I think this question was also given by one TA. So that they can discuss with me and we can give the answers. So this is mainly that the loss function is mainly because of the minimum error rate classification. So if I consider the probability of omega I given x, if it is maximum, the loss will be minimum. The probability of omega I given x, that because we considered that minimum error rate classification. If you see the minimum error rate classification, so in that case we consider that case, that is 1 minus probability of omega I given x. So like this we discuss one loss function. So that from that this problem is from that. So you can see that one. So this cross entropy concept I'll be discussing when I'll be discussing the concept of the logistic regression. So just wait for some time. This entropy means the measure of uncertainty. Entropy means the measure of uncertainty. So if you want to understand the information contained, what is the information gain or information loss? So for this we can consider the entropy. So that concept I'll be discussing when I'll be discussing the concept of the decision trees. In decision trees, we have to consider the information gain. So this entropy means the uncertainty, but from the entropy we can determine the information gain or maybe the mutual information. So if you read the books on information theory, the entropy is mainly the uncertainty corresponding to a particular random variable. X is a random variable and we can consider the uncertainty. So the entropy is the measure of the uncertainty, and also we can determine the mutual information or maybe the information gain. So when I will discuss the concept of the decision trees, and you can see how to determine the information gain from the entropy. So from the entropy we can determine the information gain. So in the week number 5, if you see the video in week number 5, that we discussed the concept of the decision trees. In decision trees, we discussed the concept of the entropy. So you see the videos in the week number 5, and that is for the decision trees. So how to determine the entropy, the information gain. So entropy is related to information. So if you want to understand more about the entropy, the information gain, so all this is available in the information theory book. But briefly, I have explained in my class what is the entropy, and with the help of the entropy, how you can determine the information gain. The information gain you can determine, and that is important in the decision trees. So that you can see. Yes. In week number 5, we discussed the concept of the cross entropy. That you can see. Because of the cross entropy, we can determine the information gain. In decision tree, we have discussed the concept of the information gain, and you can see the mathematical expression from the expression for the cross entropy. That is available in the book. Also, even in the internet, also you can search what is the cross entropy. So corresponding to a random variable, you can determine the entropy. That is the uncertainty, and from this you can determine the mutual information, the conditional information. So all these things, the conditional entropy, the mutual information, the rate distortion. So all these things you can determine. And here in my class, I discussed the information gain corresponding to the decision trees. So for mathematical expression, you see from my video, or maybe in the internet, you can search. So what is the cross entropy? So for a random variable x, how to define the entropy? So entropy, already I mentioned, this is the measure of the uncertainty. So suppose I have two events, the probability. Suppose it is always occurring. Suppose tossing of a coin. So suppose head is always occurring. One is the outcome is the head, another one is the tail. So suppose a particular event is occurring frequently, then the entropy will be less. The information will be less. Because it is always occurring, so that means information will be minimum. But if it is like this, the event is something like this, it is sometimes head or sometimes tail, the information will be more. So suppose particular event is occurring frequently, the same thing is occurring, the information will be less. But if I consider information, suppose one is head, another one is tail, randomly it is going on, the information gain will be maximum. So suppose in case of the coding, this alphabet E is more frequently occurring as compared to Z. So suppose I have the alphabet, 26 alphabet, I am considering the coding. So alphabet E is more occurring. So that is why the entropy will be less. The Z is not frequently occurring. So that is why the entropy will be more. So corresponding to a particular symbol, which is occurring more frequently, the entropy will be less. And suppose another symbol that is not occurring frequently, it is randomly occurring, the information gain will be more. So that is the concept of the entropy. So suppose the E is occurring more frequently, the letter E is occurring more frequently, the information will be less. So corresponding to a particular symbol, if it is occurring more frequently, then the information gain will be less. So Doctor, so if you have any questions, then just you can ask me here. Okay, so if you have any questions, then you can put here again. I have not seen any questions in the chat box.
So there are not any question now.
Hello?
There are not any question now, sir, in chat box.
Oh.
In YouTube as well, there is no questions.
So after 10-15 minutes, we can conclude, no? Then.
Yes, sir, of course. If there is no question, we can.
So one question is why only the sigmoid activation function used in ANN? Can we use any other activation functions to normalize the output? No, because we are considering the nonlinear. Sigmoid function is a nonlinear function. We can consider a nonlinear function. So we have discussed what is the advantage of considering the nonlinear function. If I consider a nonlinear function, you can get a nonlinear decision boundary between the classes. So objective is to get the nonlinear decision boundary between the classes. The sigmoid function is a nonlinear activation function. And if I consider this function, then I'll be getting the nonlinear decision boundary between the classes. So that is available in my video. If you see my video, I have clearly explained why the sigmoid function is considered, because the problem is the classification problem. And if I want to find the decision boundary between the classes, suppose 2 classes or 3 classes, so instead of considering the linear decision boundary, we can get the nonlinear decision boundary between the classes. So that is why we are considering the sigmoid activation function, that is a nonlinear activation function. Maybe we can consider 10 hyperbolic function, we can consider. So this is also nonlinear function. So there are different nonlinear functions, but sigmoid function is generally is used in case of the artificial neural networks, but that has a problem. So that is why in case of the deep architecture, the deep neural networks or the convolutional neural networks, we considered some other activation functions like the ReLU. The ReLU activation function is considered because the sigmoid function has the problem of the saturation. So that I am going to explain in my lecture in week number 11 and week number 12. So you can understand what is the use of the sigmoid function and what are the problems of the sigmoid function. That also I'll be explaining. And also in case of the convolutional neural network, we are not considering the sigmoid function, we are considering the ReLU function. So there are many a nonlinear activation function like the 10 hyperbolic function is there, the sigmoid function is there. So these functions are available. But in the main principle is we are considering the nonlinear function because the main objective is to get the nonlinear decision boundary between the classes. So just you see my video. That is the advantage of the artificial neural network. We can get a nonlinear decision boundary between the classes because of the sigmoid activation function. So Vikrant, you are from BMS College, Bangalore. No, in case of the artificial neural networks, we have the problem of this overfitting and the underfitting. It depends on the amount of training. The training is too much, then the problem of the overfitting. So we have to stop the algorithm. If we do not stop the algorithm, then the problem of the overfitting will take place. So based on some conditions, we have to stop the iterations. So we have to fix some conditions. Suppose the condition is like this. If this parameter is greater than a particular threshold, we have to stop the algorithm. That is the iterative algorithms we have to stop. Based on this condition, we can stop the training and the problem of the overfitting can be considered. That means can be reduced, the problem of the overfitting. And similarly, the underfitting is because of the less amount of training. So overfitting is mainly because of the overtraining. So based on some conditions, we can stop the algorithm. That is the iterative algorithms. And this backpropagation is the training technique. So overfitting may take place and the underfitting may also take place. So, but how to stop the iterative algorithms, that also we have to see. So based on some conditions, we can stop the iterative algorithms. That is the training algorithms. So if I do maximum training for the limited number of training samples, suppose we have limited number of training samples, then the problem of the overfitting will take place. If I have huge number of training data, then overfitting will not happen immediately. But if I have limited number of training samples, then the possible is the overfitting. So even in case of the artificial neural network also, overfitting and underfitting may take place because of this backpropagation algorithm. So in the backpropagation algorithm, we are finding the difference between the actual output and the desired output. That is the error. The error is backpropagated to the input. The error is backpropagated to the input. And the objective is to reduce the error by updating the weights. But if I have limited number of training samples, then the problem of the overfitting may take place. Underfitting is mainly because of the limited, overfitting is mainly because of the limited number of training samples. And underfitting is mainly, that is the high bias. One is the problem of the bias, another is the problem of the variance. So overfitting is the variance problem and underfitting is the problem of the high bias. So Vikrant, you are from BMS College, so I think you know Professor S.M. Suresh. So he's from the Department of Mechanical Engineering. Professor S.M. Suresh is there in the Mechanical Engineering Department. Yes, yes. You please convey my message to him. So just you mention my name from IIT Guwahati. So he is very close to me, Professor S.M. Suresh. So maybe we can meet in the next live session. So that will be in the first week of the September. So any questions you can put in the portal. And already I told my TAs to discuss with you. So for any complicated questions, they generally discuss with me. And after this, we try to give the answers. So if you have any problem, also you can directly write to the TAs. So I can give their email ID also. I think you know the email ID. So if you need their email ID, I can also give the email ID. Like this, I'll give the email ID. So I am giving the email IDs of the TAs. So you can note down these email IDs of the TAs. So you can see the email IDs of the TAs of the course. You can send the mail to these TAs. So now I think we have to conclude this session. I am waiting another 1 minute. If you have any questions, then you can put. Otherwise, we have to close because time is from 3 to 4 p.m. So we cannot extend because of the conflict in other courses. Okay, so do you find the course is useful? So these two students are in the chat box. Can you write yes or no? Whether this course is useful or you like the videos, just you can write yes or no. Because in this course, I am trying to include more and more contents of both machine learning and the deep learning. Okay, thank you. Course is very useful for my professor. Okay. So I'm waiting for another 1 minute. Somebody is writing. Okay, then thank you. We have to conclude this session. Very good, very good. The course is very useful. The concept was explained by my TAs, and so it is okay. I am trying to give the maximum content for the machine learning and the deep learning. So thank you for these comments. Okay, so I am concluding this session. So we'll meet in the first week of September for the second live session of the course. So thank you once again. Thank you. Thank you.